I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Armed with multicore optical fiber, researchers have taken a crucial first step toward the long-distance transmission of optical signals from optical clocks, and it could ultimately open doors for a plethora of scientific applications. An international team of researchers led by the National Institute of Standards and Technology has demonstrated for the first time that multicore fiber can support long-distance optical clock signal transmission that's compatible with telecommunications networks. More specifically, the team's work, involving a testbed and simulation, shows that ultra-stable optical signals can be transferred consistently via multicore fiber and telecommunications traffic. This could maintain the precision of optical atomic clocks while simultaneously transmitting frequencies bidirectionally, which has long been a challenge. Ultimately, this could make possible an intercontinental network of highly accurate optical clocks and advance precision timekeeping applications like telecommunications, navigation systems, and quantum clocks. The team says they're now working to strongly establish optical clock signal transmission compatibility, not only with long-haul fiber networks, but also optical amplification. Singular Photonics, a UK-based developer of next-generation image sensors, is joining forces with optics solution provider and distributor AMS Technologies for expansion into key European markets and industry sectors. As part of the new alliance, AMS becomes the primary distribution and support partner for Singular's single-photon avalanche diode-based image sensors throughout the European market, namely to OEMs, research labs, and systems integrators. As the demand for single-photon sensing grows, representatives of both companies say their partnership will essentially make the process from engineering and production to distribution more efficient and effective. In other business news, Netherlands-based photonic chip accelerator PhotonDelta is set to collaborate with Luminate NY, a photonics and optics startup accelerator, for the creation of a growth network for early-stage photonics and optics companies in the US and the Netherlands. Officials say the partnership is meant to expand access to resources and support for commercializing technologies and strengthen innovation initiatives. A new laser sintering technique is set to transform and ultimately revolutionize various industries, from aerospace and defense to energy and hypersonic travel. Researchers at North Carolina State University have designed the sintering approach that uses lasers to turn liquid or powder raw materials into ceramic materials used for applications requiring tolerance to ultra-high temperatures and extreme environments. The method basically simplifies the process. Called selective laser reaction pyrolysis, the new approach involves a thin film of polymer applied to a substrate or inserted into a mold. The team tested their method on hafnium carbide, a material with an extremely high melting point that's used on things like spacecraft and nuclear reactors. With the CO2 infrared laser, they rapidly heated a liquid polymer precursor of the hafnium carbide material, which simultaneously triggered polymer cross-linking and pyrolysis. That precursor was then converted directly into a nanocrystalline ceramic. This occurred within just minutes, the team says, unlike conventional processes that are extremely slow, energy-intensive, and unyielding. The team is now working to advance their approach for other ultra-high temperature materials and complex 3D ceramic structures. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.